differentiate hardware and software switching mechanisms, MAC address table and TCAM. Talking about this TCAM topic is difficult because TCAM is a Cisco proprietary technology. So Cisco does not provide many details, but general facts about how it works. So my take on this is going into the exam with as many facts as possible about TCAM. I'm going to talk about the CAM before going into the TCAM, because CAM was predates the TCAM as a technology, and older switches, the previous generation of switches will allocate the MAC address table inside the CAM, or content addressable memory. The CAM used high-speed memory, faster than typical RAM, to help these switches forward frames faster than previous technologies. The nature of CAM was binary because it only used zeros and ones. 0 for true and 1 for false. So the CAM was binary. And the CAM used to take an index or key value, look it up in a very fast manner, and provide a result value. So the CAM only used an index or key value and a result value. For instance, an index or key value could be a MAC address, and a result value could be a port number or a VLAN ID. Now, newer switches or multi-layer switches will use TCAM to accommodate the MAC address table. So what is TCAM? TCAM is an extension of CAM technology. The T comes from ternary, because the TCAM is no longer binary but ternary in nature. And I will talk about this a little bit later. So a TCAM can evaluate not only layer 2 forwarding as the CAM did, but also it can evaluate quality of service ACLs, security ACLs, and layer 3 forwarding. So the TCAM can accommodate the MAC address table, access list of many natures, and the routing table as well. So the TCAM is made up of masks, values, and results. And opposite to the CAM that it was only related to key values and results, the TCAM can hold masks, values, and results. And the mask can contain zeros, ones, or X for not care. That is the reason it is considered to be ternary, because it can hold 3 values: zeros for true, 1 for false, and X for not care. The X are great to hold or to store a wildcards combination. The masks come from addresses or wildcards in an ACL. One mask can relate to 8 values. The mask and values are 134 bits in length. The values come from protocol numbers, source or destination addresses, ports, permit or deny clauses. The results represent the action to be taken after TCAM lookup, like a permit, deny, an index to the quality of service polisher, or a pointer to next hop. So if I want to evaluate the routing table in one step, I compare a packet against the TCAM, and the TCAM tells me what is the next hop. If I want to evaluate a frame or a packet against an ACL, the TCAM evaluates in one single step the whole ACL and tells me whether the result is a permit or deny action. So no matter if it doesn't matter if your ACL has 100 or 500 entries or 2 entries, it is still evaluated in one step against each frame or packet. So TCAM components, the software components of TCAM are 2: the feature manager that compiles ACLs into mask and values and merge this information into the TCAM. So each time you write down a human readable ACL, the feature manager will compile that into zeros and ones and X, and it will merge that information into the TCAM table. The other feature is the Switching Database Manager, or SDM. The SDM provides you with templates that you can choose from as a user, depending on how your switch is operating. If your multi-layer switch will be doing more switching than routing, for instance, you could choose a template that has more resources for the MAC address table and less resources for the routing table. Whereas if your multi-layer switch will be doing more routing, you can choose a template that has more resources for the routing table and less resources for the MAC address table. If you choose a different template, a reload may be necessary, and you must have caution if you are stacking switches together and if they have different SDM templates, and you have to follow or know the rules of what will happen. That's it.